Well, howdy there, Internet students. This is Mr. Hermanson creating another video for you, in this case to help you learn how to find the areas of regular polygons. An important new word you're going to need to understand in order to do this, that the perpendicular distance from the center of a regular polygon to its side is called the apothem. All right, so go ahead and fill in these vocabulary missing parts, and this would be a good time to pause and you can check back and see if you got the right answers. All right, go ahead and read this problem and see if you would know the answer. All right, so we're going to learn a way to figure out how to find the area of a regular polygon. One thing you can think about while you're doing this, though, is that when we can break up a regular polygon into regular, congruent triangles. And then you could really just find the area of each of those triangles and then multiply by however many triangles there are. There'll be a formula we can use to help simplify that. All right, so the first thing we want to talk about is what are the angles once you split up a regular hexagon into those triangles. And so we'll do that right here. Now for this one, to find the measure of angle 1, that one's pretty easy. It's just, since it's a regular polygon and all of these triangles are congruent, we know that it's just 360 divided by 6, which is 60. Okay, so the measure of angle 1 is 60. That means that the measure of angle 3 is half of that, which is 30. And then once we know the measure of angle 3 is 30, then we can figure out what the measure of angle 2 is by just doing 90 minus 30, which is 60. All right. So this next problem is half of a regular octagon. See if you can figure out what the missing angles are, and I'll jot my work down for you so you can check your answers. So if two figures are congruent, then their areas are equal. That makes sense. And that's where this formula comes from for finding the area of a polygon. You can go ahead and read this and help figure it out. But basically what we're saying is, so if we take the apothem as the height of one of those triangles, and we multiply that by the base of one of those triangles, that would give us the area of one of those triangles. If we multiplied by all the bases, that would give us all the triangles. And since triangles, you have to take half of the base times the height. That's where the half comes from. So so that's our formula. Remember that A is a new term. A stands for the apothem. Okay, so in this problem, we're going to just go ahead and use that formula. We're going to do 1/2 times the apothem times the perimeter. And the apothem in this one is 14.5. And the perimeter would be 12 times the number of sides. Since it's an octagon, the perimeter would be the length of one side, 12 times 8. And when we multiply those together, we get 696 square centimeters. All right. So let's just fill these in, and then I'll let you go ahead and figure out what it is. But the apothem, which is the distance from the side to the center, is right here. That would be 8 centimeters. And the sides are each 11.6. So you're going to do 1/2 times the apothem times the perimeter to get your answer. Okay, in this one we're going to basically do the same thing, but we're going to use what we know about certain triangles to help us find some of those missing parts. So Nancy has a gazebo shaped like a regular hexagon. So let me get one of those up here. Regular hexagon. Okay. And so each side is 5 feet long. So I'm just going to write 5 there for that side. And we want to know what the area is. So to find the area, we're going to use our apothem formula. So I kind of need to know this height right there from the center to the bottom. Now to help me figure out what that height is, I'm going to draw in this triangle. Okay, it's a right triangle. And remember that if I drew one triangle in here, that this angle right here would be 60 degrees, 360 divided by 6. So that means this is a 30, 60, 90 triangle right here. I'm just going to draw that little triangle outside here so it looks a little better. So this is a 60-degree angle here, 30 up here. All right, and we know that this side down here would be 2.5 because it's half of the side length. All right, and so the height, which is the apothem, is 2.5 times the square root of 3. So I have everything I need right now. I'm going to do 1/2 times the apothem times the perimeter, which is 1/2 times 2.5 times the square root of 3 times the perimeter, which would be 30, 6 times 5. And then if I wanted in simplest radical form, it would just be 30 times 2.5, which is 75 divided by 2 times the square root of 3. But it says round to the nearest whole number, so I'm going to go ahead and calculate that. Rounding to the nearest whole number, that is about 65. Okay, so you go ahead and try it, see if you can get it. Why don't you give your answer in simplest radical form, and then it says also to the nearest square foot. Looks like you're ready to try some problems on your own. Good luck.